Welcome to Learning Chemistry with Faye. In this video, we will learn about ions and naming systems. Let's first look at what is an ion and how are they formed. An ion is formed when a natural atom gains or loses electrons. An atom has the capacity to obtain 8 electrons in the most outer shell. We call it valence shell. It has the most stable form when the shell is full of 8 electrons. However, for a lot of the elements, they do not have 8 valence electrons in the valence shell in its natural form. For example, aluminum in its natural form has a total of 13 electrons, with 3 electrons in the most outer shell. In order to have 8 electrons in the valence shell, it must either gain 5 electrons or lose 3 electrons. Since gaining 5 electrons takes way more energy than losing 3, aluminum forms a cation with 3 positive charges. For another example, bromine has 7 valence electrons. Since it is so close to have a full valence shell, it will simply try to take an extra electron from another element and form an anion with a charge of -1. With these ions consisting positive and negative charges, they will attract each other and form compounds. And here we have aluminum-bromine compound. Sometimes these formations can give quite a lot of energy to the external environment in the forms of fire or explosion. To recap, positive ions, which are also called cations, attracts negative ions, which are also called anions. The charges of the positive and negative ions must be balanced within a compound. In this case, the aluminum has 3 positive charges and bromine has 1 negative charge, which means we will need 3 bromine to balance out 1 aluminum. Therefore, the compound has a chemical formula of AlBr3. Here is a version of the periodic table that shows the patterns of some of the elements when they form ions. For example, group 1 has a charge of +1, group 2, +2. The halogens all have a -1 charge. The next one are the oxygen columns with the charges of -2, and the nitrogen columns with the charges of -3. Remember, aluminum has a charge of a +3, even though the group in the group 13 is kind of grouped to the right. And then carbon is actually positive or -4 since it has 4 electrons in the most outer shell. It also shows the charges to some of the polyatomic ions that can formed by the transition metals. Polyatomic ions means the element can take on different forms of ions with different charges. For example, copper can take on the form of positive charge 1 or 2, and the gold can take on a positive charge of 1 or 3. Once a compound is formed, how do we name them? They are named with positive ions first, then the negative ion follows. After that, we change the ending of the negative ion to "ide." In our example, the compound has elements of aluminum and bromine. Therefore, the name of the compound is aluminum bromide. Let's try a few other examples. A compound with elements of barium and chlorine is called barium chloride. So here you can see barium has a charge of 2+, while chlorine has a charge of -1. So you need 2 chlorines to balance out 1 barium. So you have the chemical formula as BaCl2, and it's called barium chloride. And we also have sodium and phosphorus. So with the elements of sodium and phosphorus, you will need to balance 1 phosphorus, which has a charge of a -3, with 3 sodiums, which has a charge of a +1. and the compound is called sodium phosphide. And the last example, a compound with elements of gallium and sulfur, is called gallium sulfide. I want to make a note here. Remember, the charges of transition metal ions are not very predictable and must be specifically identified by the Roman numerals in their names. So remember not to confuse the Roman numeral numbers with the quantity of the elements. They're not representing the quantity of the elements, but they are representing the charges of the transition metals. For example, nickel 2 chloride. Without specifically notifying the charges of the nickel, we wouldn't know how many chloride elements are needed in this compound. Therefore, we put a Roman numeral number in the names of the compound with the parentheses to identify the charges of the transition metal nickel. In this case, is nickel 2 chloride. And they also let us know that we need 2 chlorine to complete the compound. For another example, chromium can have the charge of +3 or +6. Therefore, we need to identify the charges in the compound. From this particular formula, we know that fluorine has a charge of -1. Therefore, this particular chromium must have a charge of +6. And therefore we name it chromium 6 fluoride. For our last example on this page, we have titanium and nitrogen. So without specify what titanium's charges is, we wouldn't know how many nitrogens. So in this case, we're going to specify that with nitrogen has a -3 charges, since we have 2 of them, we have a total of -6 charges while splitting between 3 titanium. That means our titanium has a charge of +2. So in this case, we will write titanium 2 nitride. Sometimes a group of ions bond together to form an ion. These ions are called polyatomic ions. They are treated as one ion in the compound. They can be positive or negative. Here I showed 7 most commonly used polyatomic ions. So there are nitrate, sulfate, carbonate, phosphate, hydroxide, acetate, and ammonium. So it is in your best interest that to remember all of these polyatomic ions. They are not conclusive. There are many more polyatomic ions, but these are the 7 that's most abundantly used in basic chemistry, that we see them very often. So make sure that you either memorize them or at least recognize them in a compound when you see them. So let's go over a few examples with polyatomic ions in them. The first one is a potassium carbonate. So you have a potassium, and remember carbonate, CO3, has a charge of -2. So you will need 2 potassiums with a charge of +1 to balance out. And the name of it is potassium carbonate. The second example, we have calcium phosphate. Notice there is a parenthesis around the phosphate because you need 3 of these polyatomic ions. You got to remember to put the parentheses around the entire polyatomic ion to represent its quantity. And last, we have ammonium sulfate. Here you have a positive and a negative polyatomic ions in this compound. In order to identify them, remember to put the parentheses around the polyatomic ions that you need to have multiples of. okay, and to quantify them. In this case, the compound is called ammonium sulfate. Since sulfate has a charge of -2, and we will need 2 ammonium ions to balance it out. Since each ammonium ion only has a charge of a +1. This concludes our video, and I hope that you have learned a lot through this video about ions and the naming systems. Click on the like button to let me know that you have learned a lot and this video has helped you, and I will see you in the next video.